Now. So the way this is mostly going to work is I'm going to start it off and see if you guys have any questions right away. I'm going to go through those questions, ask them or answer them to the best of my abilities, and then we're going to go through the study guide really, really briefly, and then that'll pretty much be it. So does anybody have any questions right away? If you have a question, you can go ahead and type in the chat and I can call on you, or you can type the question in the chat, whatever you guys feel is the easiest, or you can just start talking.
Can they be questions about the exam specifically, or do you want them just on the material right now?
I mean, it doesn't matter. Whatever you guys have a question for, you can go ahead and ask what you want to ask.
Okay. During your lecture videos, you talk a lot about like the graphing. Will you have questions on the exam where we need to analyze the graphs?
I believe there are a couple questions where you're looking at a graph. Essentially, it's going to be you interpreting the information that it's giving you. So it might be something like it's giving you like the relative lactate concentration of two individuals, and based on that, who do you think is going to be better at who's going to perform the race quicker or something like that. It's not going to be too they're not going to be too in depth. They should be ones that you've seen before. I'm not trying to switch anything up on you or make you unsure of what you're looking at. It's definitely gonna be something you've seen before, but yes, there will be a couple graph questions.
Okay, thank you.
Mm-hmm. Anybody else? Don't be shy, y'all. Come on now.
Can you hear me?
Yes, I can.
Yes. Following that question that you said about the graphs, I noticed on your bonus lecture you were talking about the essays questions and stuff.
Yep.
Are you talking about the essays question will be regards into those graphs or no?
No, so the essay questions are all concept questions. So they're going to be asking you specifically some sort of cause and effect. I don't want to lead too much into it and tell you exactly what these essay questions are going to be on. I mean, I kind of already have told you what they're going to be on by the bonus lectures themselves, but essentially it's going to be asking you to list some sort or to like describe some sort of process.
Okay.
So the first bonus lecture is on the action potential from the central nervous system down into the muscle and the muscle through its cross recycling and its force production. So yes, that one I would make sure that you know the process of what's occurring. And if you don't know or you don't know that off the top of your head, I would definitely recommend reviewing those lectures because, as I said, I feel like that is a very obviously fundamental part of exercise physiology as it just describes the basis of muscle contraction in general. That answer what you need to know?
Yes, that answer. Thank you.
Anybody else want to shoot out one right away?
Are you going to be reusing like questions that you used on quizzes?
So there'll be some questions that are very similar to quiz questions. I wouldn't count on the fact that they'll be identical, as well as I would be careful to read questions very, very carefully in order to make sure that I know that people aren't just regurgitating the exact same answer that they remember from the quiz. I have changed some of the questions. Now, I haven't just like changed the word from not or something just to make it tricky. I've reworded the question, but they're going to be questions that seem very familiar, but they're going to have a different answer if that answers your.
Yeah, okay.
And something I'll say right now too, going forward is I know that online classes, especially during COVID, have had the really, really laid back mentality. And I'm not trying to be an asshole here and make this class extremely hard for you guys. I'm trying to provide an exam that is testing you on the material that I lectured on. But I will say this, that most online exams that I have taken, as well as I'm sure you guys have taken in your undergrad, are relatively easy. I'm warning you right now, this exam is not going to be overly easy. I don't think it's that hard because I don't think that I'm providing you with any tricky information that I didn't lecture on. As I was writing the exams, I was literally rewatching my lectures, and anything that I spent more than a few minutes on, I would write a question about. So it's coming directly from my lectures, directly from the PowerPoints. I just wanted to warn you guys, because I have 106 kids or 106 students in this class, and only like 30 of you respond to the doodle, that this isn't going to be an exam that you could study for about half an hour and pass. It's going to be a little bit more difficult than that, as this is a 4th level course, and this is the main course in kinesiology, it's exercise physiology. Just, it's going to take a little bit more effort than that. Anybody else?
I have a question on some of the material.
Okay.
For the like you said that the SA nodes, like it initiates the rhythm of the heart.
Yes.
So if that were to be damaged or like not function properly, could that like I guess initiate an irregular rhythm of the heart or like AFib?
Yep. So, okay. So AFib is usually due to rapid depolarization of the atria or some sort of inconsistent depolarization of the atria. If you were to just say remove the SA node, if that's all you did, the natural depolarization of the cardiac cells is 100 beats per minute. But what will happen is sometimes the SA node will become malfunctioning, or it won't fire fast enough. And that's what you'll see if you've heard grandparents that have had a pacemaker. They literally have a electronic instrument that's stuck where the SA node is that is firing every so often, and that you can turn up and down depending on how active you are. So yes, if there was some sort of damage to it, you're going to have some sort of irregular pattern, or you might have some sort of tachycardia, which would be a fast heartbeat, or bradycardia, which would be slow heartbeat, but it wouldn't necessarily send somebody into AFib. That's a good question.
Thank you.
I'm sorry to make you repeat yourself, but you were saying that if there is no SA node, then the natural BPM would be 100 beats per minute.
Yep. So sorry, go ahead.
Or that's with the SA node.
So that's without the SA node. So the natural heart rhythm of the cardiac cells, because there's the leaky channels. I don't think we talk about that in this course. We don't go that in depth for it. But essentially, there are sodium channels that are leaky, and the rate at which they leak makes the cardiac cells go through a contraction cycle at a rate that is 100 beats per minute. So the SA node actually gets parasympathetic stimulation that has to slow down the natural heart rate of the cardiac cells. So I don't know if we talk about it in this course or not, but realistically, as you guys begin to exercise, let's say you're at rest and you get up and you walk up the stairs, right? As much as we all would like to not admit it, our heart rate probably gets up to close to 100 after we walk up a couple flights of stairs. So when you go from rest where it's at 60 and then you start walking and you're going up these stairs, you don't actually have sympathetic stimulation causing your heart rate to increase right away. What you're actually doing is you're having parasympathetic withdrawal. You're withdrawing that parasympathetic stimulation, which is what's allowing the heartbeat to go up to 100. And then once it gets up to 100, anything over 100 is now sympathetic stimulation. Does that make sense?
Yeah, thank you.
And that's more in depth than I have any questions for this course. But it's a good thing to know so you understand the basis of what the SA node is doing.
Yeah, thank you.
And I apologize if I'm hard to understand right now. My allergies right now are absolutely kicking my butt. So I'm trying my best to enunciate for y'all. Anybody else got something? I figured that's how this would go. Okay, so I'm gonna pull up the exam review, the study guide. I'm gonna share my screen with you all here. Give me a second. Okay. Can you guys see the exercise physiology guide right here? Yes, I'm seeing some nods. Yes.
Yes.
Okay, so this is the basis. I tried to make this cover all the concepts. When I wrote this was me going through my exam and talking about each individual thing that's on the exam. Now, I didn't want to go too much into detail, as a lot of this stuff is concept based. You need to understand the concepts of these things, but I'll kind of go over them right now. As I go over these things, if you guys have a question, feel free to interrupt me and blurt something out, okay? So no muscle contraction occurs in all the individual proteins, ions involved within the muscle. I have a typo there, nice. Within the muscle, as well as the stimulus as well as where the stimulus for muscle contraction comes from. So this is what that bonus lecture is about. Essentially, I'm saying you should know that action potential originates in the brain, travels down the spinal cord to the level where it's going to exit the spinal cord. And then from there, the alpha motor neuron goes to the muscle. You have acetylcholine release from the alpha motor neuron, which then attaches to the motor end plate or to the muscle cell, causing it to depolarize, We should know that when it depolarizes, you have a release of calcium from the cytoplasmic reticulum. You should know where that calcium bonds to, and that's the troponin. Moves the tropomyosin off, which allows the myosin and the actin to bind and allows you to go through cross-bridge cycling using ATP. And I went through that really fast, but that is the basis of what you need to know. So if you don't know that stuff or that seemed like a lot to you, I would make sure that you can write all that down in order without having any help. Know muscle anatomy and function. So know the basic muscle anatomy, know what fascicles, muscle fibers are, know what the different things are, know what the epimysium, paramysium, and endomysium are. Know fiber types. So know that type 1 is going to be your long-lasting aerobic fiber. And if you tie these in with the other things that we've learned, long-lasting aerobic fiber probably relies on the oxidative energy system. If you haven't made that connection yet, hopefully that's making the connection for you. You should know what type 2A is, what type 2X, and what type 2B fibers are. You should know about their ability to develop force. So remember that any cross-sectional size of a muscle fiber, let's say you have cross-sectional size of the quarter, like cross-sectional size of about a quarter. You have a quarter of type 1 fibers, and you have a quarter size of type 2X fibers. Those are fundamentally different fibers, but if you give them both enough time to contract, they're both going to produce about the same amount of force. The difference is that your type 2X fibers produce force much more quickly. And that's hence why they get their fast twitch muscle fiber names, okay? So then you should know what activity they're used for. So if you're trying to do an activity like sprinting, we should know what muscle fiber types we rely on. And you should assume, since type 2B and type 2X are our fastest contracting fibers, they're probably the ones we rely on most heavily for some sort of sprinting bout. And then you should know which contain mitochondria in high amounts. So again, we look at type 1 fibers. Type 1 fibers are your long-lasting fibers for aerobic populations or for aerobic exercise. What does aerobic exercise entail? Well, it entails oxygen. And what organelle uses oxygen? Well, the mitochondria, right? And so we should know, or we should be able to essentially assume that since type 1 fibers are aerobic, that probably means that they have more mitochondria than type 2X and type 2B. So with what I just went over, does anybody have any questions about that so far? No, all good. And again, I'm going to reiterate the classic middle school thing. If you guys have a question about it, more than likely somebody else is wondering the same thing. So don't feel down if you blurt something out. So next, we're going to talk about knowing the types of contractions. So know our contractions, know what isometric means, right? Stable length, so you're not moving at all. And then you have concentric, which means shortening. And you have eccentric, which means lengthening. And know the sliding filament theory, so know the basic theory of what's occurring. So we talk about the sarcomeres, how they essentially function as just sliding. You can think of them as literally just proteins sliding past each other. So the actin and the myosin, I don't really have a better way of showing this, but the actin and myosin literally slide past each other as they shorten and as they lengthen. And that's essentially just a theory that describes how muscle contraction occurs. So you can imagine if you have a million of these sarcomeres in sequence, as they all shorten, the entire length of the muscle body will shorten. Know all 3 energy systems. So we have the phosphagen or the ATP PCR system. We have the glycolytic system or glycolysis, anaerobic glycolysis. And then we have the oxidative system, sometimes also called aerobic glycolysis. So we should know the relative complexity of these things. And then finally, we have fat oxidation, beta oxidation. And so you should know the complexity of these, and you should be able to think about this in an inverse relationship. If the reaction of the energy system is more complex, if it has more steps, the rate at which it produces ATP is going to be slower. And if it has more steps, that means it's probably more efficient. So like the phosphagen system can produce ATP very, very quickly, kind of like a firecracker, it pops off, but it runs out of substrates very, very quickly. And so therefore it is inefficient, but it is very, very fast at producing ATP. As well as you should know where these are occurring. So phosphagen and the phosphagen system and glycolysis are both, or excuse me, phosphagen system and anaerobic glycolysis are both occurring in the cytosol. Aerobic metabolism, aerobic glycolysis, and then aerobic beta oxidation of fats are both occurring in the mitochondria. So we should know where those are located. As well as to help you as a hint there, mitochondria is where oxygen is utilized. So if you think about it, okay, mitochondria uses oxygen. what two energy systems or what two energy processes use oxygen? Well, they must also be located in the mitochondria then. Know what macronutrients are used for relative exercise intensities. So we should know, or we should learn by time of the exam, that carbohydrates are going to be your fast energy supply. So carbohydrates are what you're burning when you're doing high intensity exercise or moderate high intensity exercise. Somebody have a question? No, I heard something. Okay. And then fats are what you're going to burn mostly at rest. So as you do low intensity exercise or you're at rest, you're going to burn fats. And so this is the idea. If you guys know any people that are gym bros or they're high aerobic trained individuals, they eat a lot of carbohydrates because carbohydrates are what you utilize in high intensity exercises. That's why if you look into the literature, you'll see people that have really low carbohydrate diets and really high fat diets as an attempt to do a low carbohydrate weight loss program. They will be really, really lacking in high intensity exercise because they just are completely depleted of carbohydrates, which you need for that high intensity exercise. So know the calories per macro. So your calories per macro, 9 calories per gram of fats, and then 4 calories per gram of protein, 4 calories per gram of carbohydrate. And then if you enjoy your White Claws or your vodka, 7 calories per gram of alcohol. So for each of those macronutrients, know the differences. You'd be surprised how many people I talk to that are fourth year students, and I've said this before, that do not know that a gram of carbohydrates and a gram of protein yield the same amount of calories. Know where they are stored. So know that glycogen is stored in the muscle and in the liver. Adipose tissue is obviously stored all around the body. And then when you eat proteins, they are broken down into amino acids. And those amino acids are later used to synthesize proteins. So those proteins are primarily in skeletal muscle, but they can be used in other areas as well. And know the processes that they are important for. So like I just described. Do I have any questions so far? No? All right, we'll keep going here. So know what activities utilize which bioenergetic systems. So this can just be thought of as a needed basis. So if you have some sort of super high intensity exercise, like a 40-meter dash, let's say, what energy system provides the fastest ATP? Well, the phosphagen system, of course. So that's the energy system that you are primarily relying on for that bout. Remember that the use of an energy system is based on both time and intensity. So if I were to get up and walk to the door and it takes me 5 seconds, yes, that 5-second window is in the phosphagen system. It's within the phosphagen system's window, but the intensity of it is not. So realistically, what I'm probably relying on is beta oxidation of fats or relying on the oxidative system breaking down glucose because it's such a low intensity bout. Does that make sense? I'm seeing one face, one camera on nodding yes. So I'm just using that as the indicator.
Yes.
Perfect. Okay, so remember that they are intensity dependent and time dependent, and then know the relative windows of those times. We should know that glycolysis is mostly used from, or the glycolytic system is mostly used from 10 seconds up to about 120 seconds, maybe up a little bit more, maybe up to 180 if you're really well trained. So anything after that long duration is going to become primarily the aerobic system. But once again, just because something is 100 seconds long, if it's low intensity, it does not necessarily mean you'll be utilizing the glycolytic system. Got that. Know the function of insulin and glucagon. So insulin is what stimulates the intake of glucose from the bloodstream into the muscle cells. And glucagon is what causes the mobilization of glycogen primarily from the liver so that it can be transferred through the bloodstream and move to the muscle cells, if that makes sense. Know what RER is? RER is our respiratory exchange rate. So this is essentially telling you, this is a proxy measure telling you what substrate you are burning. And so if any of you have ever seen a VO2 max test before, I don't know if any of you are in the assessments course, when you do a VO2 max test, you will see people start out and their RER at resting will be around 0.75, 0.8, some are kind of low. And as you begin to exercise more intensely, as you begin to shift from the utilization of fats to the utilization of carbohydrates, you see the RER get closer and closer to 1 and then even go over it. So essentially what it is it's a measurement of the carbon dioxide that you're expiring versus the oxygen that you're consuming. And it allows us to understand what substrate you're primarily using for your exercise. Stroke volume and heart rate adaptations to exercise. So know what's happening to these things after some sort of chronic exercise. So as well as acute exercise, know what's happening to stroke volume and heart rate as you begin exercising. We should all know that. We can feel that. We know that as we begin to exercise, our heart rate goes up, and more than likely our stroke volume goes up to increase cardiac output, as well as after chronic training, if you take the heart rate of, let's say, a really aerobically fit person, you can find heart rates as low as 40 to 45 beats per minute because they're so fit, because their stroke volume is so high at rest. And so know how these things change across training cycles or over like a long-term duration, as well as know how they go up and down during acute exercise. Cardiac output, we should know that cardiac output is stroke volume times heart rate, and it's just the relative amount of blood flow through the heart or being pumped out of the heart per minute. Know the flow of oxygen from the atmosphere to the muscles. So we should know how oxygen gets from the atmosphere into our alveoli and then transfers across the alveoli into the perfusing capillaries. Those capillaries carry it back to the heart, and then it gets pumped out via the arteries through the capillary beds in the muscles. And that's oxygen diffuses from those capillaries into the cells and into the mitochondria to be used to produce ATP. No or accumulation hypothesis. So this and no depletion hypothesis. So these are our two hypotheses behind why we feel fatigue. So the first one, accumulation hypothesis, is talking about acidosis, the accumulation of these hydrogen ions, what these hydrogen ions do. One of the primary things that they do is that they get in and they kind of muck up the calcium release in the sarcoplasmic reticulum. So not only do they cause you to release less calcium from the sarcoplasmic reticulum, which is going to downregulate muscle contraction, as well as the hydrogen ions themselves kind of get in the way of these calcium ions. I'm not going to get too deep into it, but essentially they decrease the affinity of these calcium ions to attach to troponin, which means that there's going to be less cross-bridge cycling occurring, which means less force production, hence why you can't lift the same weight 100 times. ADP, so adenosine diphosphate, and PI, which is the inorganic phosphate that has been cleaved off of ATP. These also accumulate during exercise and manifest as fatigue. And then depletion hypothesis is essentially you running out of substrates. So your muscles have glycogen in them, and then your bloodstream has glucose in them. As those substrates, the fuel for your fire, begin to burn out and you begin to not have enough of it, you begin to feel fatigue. So this is what's called in the marathon. If anybody's a marathon runner, you can correct me if I'm wrong. I'm pretty sure it's called like Dead Man's Mile at mile 19, or in the Boston Marathon, it's like
It's the hill.
what'd you say?
It's the last hill of the Boston Marathon.
Right. It's the last hill of a marathon. Also generally occurs around the 19 to 21 mile mark, which is generally when people have not been supplementing during the race with glycogen or with glucose. They will have completely deplenished their liver and muscle glycogen stores, which will cause them to essentially collapse or fatigue to a point where they have to stop running. And so that is the glycogen depletion, as well as for our phosphagen system. We know that the PCR gives the phosphates to the ADP, quickly making ATP so that you can burn through that really, really quickly. As that PCR becomes depleted, we no longer have some sort of source giving us fast phosphate to attach to our ADP, and therefore you become fatigued really, really quickly. This is like if you guys run sprints. When you get to about 6 or 7 seconds of sprinting, you begin to slow down because the PCR is beginning to become depleted. As well as we talk about creatine supplementation, if you can supplement with creatine and saturate the muscle stores, you are essentially upregulating the amount of PCR that is being stored within the muscles as well. And so now, as you do each subsequent set, you are allowing the replenishment of PCR to be more efficient, which means you can work each subsequent set at a higher pace or higher intensity, which will equate to more muscular damage, which means more muscular adaptation, which means more gains, whether that be sprinting or whether that be lifting or something like that. And then ATP depletion. We know that ATP depletion is ATP is the energy currency of the cell. I've probably said that a million times in my lectures. If you're running out of ATP, you're running out of the main or the only energy source for completing muscle contractions. And so if you're not completing muscle contractions, you're not moving. Know what sports drinks and supplements are used for and why they may be effective. So talking about sports drinks, the primary use of sports drinks is actually a misnomer for most people. Most people don't know what it is. It's actually just for glucose replenishment. So sports drinks, let's say Gatorade is a decent sports drink. Yes, it does replenish ions or salts that you lose in your sweat. But one of the primary mechanisms by which Gatorade is effective is that it provides you with carbohydrates throughout your intense activity. And so, like I said, during a marathon, if you watch the marathon very closely, somehow if you have the patience to watch for 2.5 hours at a screen and they happen to give you the right camera shot, or if you're involved in it, you will find that the premier athletes are sucking on carbohydrate gels, or they're chewing on carbohydrate gummies, or have some sort of highly carbohydrate drink. As well as, if you are a big Tom Brady fan, whether or not you hate him or whatever, his sideline drink is notorious for being terrible tasting because it is extremely concentrated with carbohydrates, and it is extremely concentrated with the ions that he loses during sweat from sweat when he's playing. And so that these sports drinks, are primarily for carbohydrate replenishment, but also they're used for replenishing the ions that you are losing during from sweating during exercise. So I just covered a lot. Does anybody have any questions they want to stop me out here? No? Okay, cool. So know the FIT principle, know our five types of training principles, know overtraining, know the symptoms of overtraining. This is something that's lost a lot in practitioners in the field right now, specifically strength coaches. Coming from the University of North Dakota, we had a massive overreaching and massive overtraining program or a problem in our football team. We had strength coaches that were from the early 90s that just refused to look at any recent literature. They were having massive hamstring problems. They were having guys that were basically collapsing on the field 7, 8, 9 games into the season. And then just were not able to play the rest of the season because all their nagging injuries were not going away. This massive overtraining program is something or overtraining paradigm is something that's looked over a lot in strength coaches, athletic trainers, just people in general. And so it's something that I think that you guys, if you're going to be moving into those fields, PT, strength coaches, whatever it might be, I urge you to look more closely at this so you can understand what's going on here and help you to be a better coach going forward so you can modulate your training programs so that you're not overtraining your individuals, because acute overtraining can be fixed relatively quickly. You can get people to take it easy and you can get them back on the field at tip-top shape within a week or two. But if you have someone that's been overtraining for a month or two, it may take years for them to fully recover. And so this is something that's becoming more prevalent in the literature now, is that I don't know if any of you guys ever felt this, where you get about 3/4 into a season and you just feel absolutely burnt out and you just cannot do anything that you were able to do at the beginning of the season. It's usually because of some sort of effect of overtraining. And so now this is beginning kind of woven into a lot of professional programs, college programs, looking at this and saying, hey, what are these symptoms? How do we modulate for these things? And this is part of also your training paradigm or your training programs, knowing how you increase load and then decrease load. We talk about traditional and non-traditional periodization. And then describe how genetics alters training and adaptation. So we all know that you can work harder and you can become better at what you're doing, but essentially you always have a genetic ceiling. Could I be a all-star in the NBA? Absolutely not. I'm a 6'1", non-athletic individual, or moderately athletic if you go back to the small town, but in the general consensus of the world, I'm a non-athletic dude. And so even if I were to go through a massive training regimen, first of all, I'm 6'1", which is not going to help. But second of all, my genetic ceiling is going to probably prevent me from playing in the NBA. Now, that can maybe be an excuse for why I'm not there, but it applies to all people. Some people, throughout your exercise or throughout your sports, don't have to train at all, and they're going to be a premier athlete, versus you have people on the team that work their asses off, and they're only ever a moderate athlete. As well as some people are just higher responders to training. Some people will go through the exact same training protocol as the person on the left and the person on the right, but they will respond much more quickly to this. I have a friend of mine that played in North Dakota State University. In high school, he was a relatively decent athlete. He wasn't all-state or anything. He got to college and he put on 110 pounds and increased all of his lifts by over 100%. And now he's going in the first round of the draft as an offensive lineman. So you can see there, he just wasn't training in high school. And once he got to college, he was a super high responder to training. And obviously it benefited him. And now he's going to be an NFL athlete making millions of dollars. Looking at these, know the 5 fundamental principles of the training program. So individuality. So like I'm talking about right now, each individual athlete is going to react different to a training stimulus. And so this is something, if you guys are PTs, OTs, strength coaches, you have to watch individual people very closely so that you can understand, hey, this person is high responder, low responder, they're responding well, they're recovering well, whatever it might be. looking at specification, if you want to make your sprinters better at sprinting, having them do really, really slow contractions or having them go out and run 10 miles is probably not going to be the most beneficial thing for them. There's always some merit in mixing up your training styles, but obviously if you want, Joe Blow to be a premier sprinter, you're not going to be having him run 10Ks every day. Reversibility, remembering that as you begin to take rests, after a certain period of time, you begin to lose those gains. And so this is the primary concept why the overtraining paradigm was so prevalent, is because people said, oh, if you don't work out for 2 weeks, you begin to lose some of your aerobic gains, or you begin to lose some of your strength gains. They thought, well, we can't let anybody take any time off because then they'll be losing these things. And so this is the idea that you use it or you lose it. So remember though, that it takes quite a bit of time. You'll hear people be like, oh, I didn't work out over the weekend and I go in on Monday and I already lost all of my strength gains, or that doesn't happen. Okay. That's primarily a placebo effect in your mind. But the idea still stands strong. If you are not using some sort of muscular strength mechanism, power mechanism, your aerobic systems, energy systems, if you're not using them, they're going to be reversed and you're going to begin to downregulate whatever you need to make them efficient. Progressive overload is the idea that to get optimal gains out of individuals, you need to continue to make the training program harder. So with this, we talk about periodization, how you kind of have 3 progressing harder days, then you have an easy day, but then 3 progressing harder days and an easy day, or 3 progressing harder weeks, or whatever it might be, an easy day. You work your way down, but you do it in a stepwise fashion, kind of like a stair step. You don't just go someplace in a straight line. You don't get better in a straight line. You have to allow yourself to recover in between those. And so progressive overload is the idea that if you want to get faster, you have to make your workouts harder. And I'm sure you guys have understood this as you go through gym training or in sports. To get better, you need to train harder and harder over time. Otherwise, you'll maintain and you'll be at a steady state. And then finally, periodization and variability. I've kind of touched on these couple of things already. Periodization is the idea, like I said, where you have kind of like escalating levels of intensity and then you drop, and then escalating levels of intensity and then you drop. And then variability is the idea that even if you are primarily an anaerobic athlete, I think I talked about this example before, the hockey team at the U of M was having problems that they're having their athletes burn out in the 3rd period. And that's a premier hockey team. I don't know how good they've been recently, but in the 90s and early 2000s, they're very, very good. Well, they completely changed their training paradigm to only training in the 45-second window, which is how long a shift usually is in the ice, give or take 10, 15 seconds. Or if you're a real hockey nut, the defensive men are on the ice longer than that, I understand. But for the most part, they're in this training window. And so they only ever did sprints that would last 45 seconds. That's all they did. And they begin to have manifestation of fatigue later in the periods and later in the season, because they were not providing any sort of variation to their training, as well as just basic fundamental things they were usually doing it well at the beginning of the season began to break down because they were not training those things any different. They were doing the same thing over and over and over. So that's a real life example of the fact that you need to change what you're doing. Otherwise, your progressive overload might not be as effective. And then finally, looking at length of training periods. So know what a mesocycle is, what a macro cycle is, and know generally what standard and undulated periodization is. So good luck to you all. Do you guys have any other questions right now? I know I went through that really fast, and I know this is an online course, so it's kind of difficult for me to get the information to you in a manner which makes you guys digest it easily. So this is really the only time where you guys have a chance to answer or ask questions. So please, if you have anything at all, reach out to me here.
Going back to overtraining and the symptoms, there was 12 that were like mentioned in the PowerPoint. Are there some symptoms that are more prominently shown in an athlete when overtraining is present?
Give me a second here. I'll pull up so I can find the 12 that you're talking about. So yes, there are going to be some that are more common. Let's see if I can find the slide that you're talking about here. Give me a second. Can you guys see? You can still see the study guide, right? Now, can you see the slide?
Yes. Yes.
Perfect. So loss of performance. So the first one that you're usually going to see, or the first couple that you're usually going to see, is you're going to see fatigue and loss of performance. So we had a D1 hockey player. So the University of North Dakota that I came from is one of the premier, if not the #1 rated hockey school in the country. And so whenever these players come in, they're usually already drafted for the NFL. I would say, I think there's 35 or some kids on the roster. Usually like 20 to 25 of them are already drafted. So we had a kid that got hurt and he was beginning to lose playing time after he came back, and he was getting tired and he was feeling fatigue and he was just not skating as fast as he was. And after a long kind of arduous process of talking with the trainers and whatnot, eventually he found out that he was just overtrained. He was having massive loss of performance and he was having fatigue, as well as during this time, we found out afterwards that he was starting to have a lack of appetite. But mainly what you're going to see manifest first is you're going to see loss of performance. You're going to see fatigue, excess soreness, and then you will see heart rate changes. Obviously though, to see heart rate changes, you need to have some sort of heart rate monitor on them. So as a trainer, to answer your question, you're probably going to see fatigue, you're going to see loss of performance, and you're going to see excessive soreness occur first.
Okay, thank you.
Welcome. Anybody else?
Are you able to move the slide real quick? Because I was real quick.
Slide over like that.
Yeah. Well, because I can remember exactly what you said about the length training period. What was the last thing? Because I know there's no bullet points there. I just couldn't remember what you exactly said about it.
So length of training period, make sure you know what a meso, a macro, and a microcycle are for length. So I'll bring this back. So know basically what these are and differences. So I don't know if I have a question specifically asking you how long is a microcycle, because there's plenty of people that would argue that a microcycle could be as small as a day. But you should know based on their names, essentially, which ones are longer. You should know the microcycle is the smallest one, around 2 weeks. Mesocycle is the medium length one, around 2 months. And then a macrocycle is 4 months, could be as much as a year.
Thank you.
Welcome. Anybody else?
Are there going to be any questions where we need to label things, or is it all multiple choice other than like the essay questions?
So that's a good question. Yes, there are going to be questions where you need to label things. So a couple of them, since you guys are here, and since there's only 10 of you guys, that's less than 10% of people in this course, I'm gonna start to give you guys some more hints. So there's gonna be some questions, particularly on like muscle contraction speed or bioenergetic use, where you're gonna have a list of them and you're gonna have a drop-down bar that says, okay, fastest contraction speed, which type of muscle fiber, or relies primarily on oxidative metabolism, what muscle fiber. So there's going to be questions, yes, where it's going to be kind of a drop down, as well as I think I have a couple of short answer. It's not short answer to where you have to type out like a few sentences. It's something me asking you like, I don't know, a lengthening muscle contraction is known as a what contraction. I don't think that's on the exam at all, but it's something where you just write in a word like that.
Okay, thank you.
Yes. Anybody else? Okay, so I'll kind of wrap this up here. Maybe I shouldn't have recorded this because nobody's showing up, but there's less people here than I'd hoped, but hopefully people are kind of picking up on what's going to be on the exam here. For the exam itself, remember you guys have the entire week to take it. Do me a massive favor though, please do not wait until the last day, because I believe I have it open until, I think I have it open until the 26th or the 27th, something like that. I can't remember off the top of my head right now. If you're sending me emails at 9 p.m., the last date's due, and you're saying that your Wi-Fi crashed or whatever it might be, there's a pretty good chance I'm not going to respond to you. Like I said, I like to have my own life. I don't like being on my email and doing work until 10 p.m. every single night while I'm in an exam window. So try to get it done as early as you can. As you guys go through the exam week, if you're studying and you're saying, hey, I'm going to take it on Friday, as we go through the exam week here, if you have more questions that you want to ask me, go ahead, please do so. I'm here as a resource to help you guys out. And then remember, the exam is closed note, closed book. You can't use anybody else as a source. We had it happen last year with last semester with one of the exams in the program. We had 2 people sitting in the same room, clearly talking to each other while they're taking the exam. I would hope that if you guys are going to cheat on your exams, you'd be better at it than that. So at least be good enough at cheating that I can't tell that you're cheating, essentially is what I'm saying. But for the most part, yes, you can't use any outside sources. You can't have your notes open. You can have your books open. I've had a couple people, like I said, with the quizzes, email me and be like, hey, can I use content on the quizzes? If you guys read the instructions, you cannot use content on the quizzes. Same with the exam here, okay? Other than that, does anybody have any last second questions here? No? Okay, so appreciate you
didn't
guys
have a-
coming.
I didn't
I
have
hope
a
you guys.
question,
Oh, go ahead. Go
but
ahead.
I appreciate you like going over it and stuff.
Yeah, man, I thanks for saying that. I think one of the good things about this exam session review here is that I'm gonna catch more of the students that are more apt to try to do well in the exam. So for those of you guys that are here, you're already doing well for yourself, as well as I'm going to imagine those of you that are here, you'll probably get a kick out of it. This exam 1 may not go well for a lot of people. So I would imagine exam 2, there's gonna be a lot of people that are in the exam 2 review session. So as a note, any of you guys that are here right now are probably going to have a little bit more leeway towards the end of the semester if you're vying for that A and you're at an 89.7. So this is one of those things. This is the only interaction I have with you guys. To be completely honest, I don't like teaching this course online. I think this course is way too involved to be taught online. And so me trying to teach you these things just through basic lectures, I don't think is very, very good. So this is my only time to interact with you guys. So I do appreciate you guys being here.
Last last question. Where will we be able to find this recording? Because I'm gonna be watching this like 20 times over and over.
So I appreciate you trying to listen to my voice that much, but I'll post it on the exam right below the study guide. So if we go into, you guys can still see my screen, correct?
No.
No? Oh, that's right. Okay, hold on a second. Da-da-da. Yeah, you
Now we
right?
can.
Looking at so if you look at the exam tab right here, I'm going to post it just right here. So there'll be a link. I'm going to post this on YouTube just like the rest of them. So give me a little bit of time for this to download to YouTube and then myself so I can upload it on my profile. And then I will post the link to the review session right here. As well as a note for you guys, these bonus lectures are very important. They probably have a lot to do with the essay questions. So
Yes.
keep a quick look at those. If not, look through the PowerPoints really quick and you guys should be good to go. Any other questions for me? And then as a final note, I'm gonna post an anonymous survey. I promise it's anonymous. You'll be able to write any comments you have for the midpoint of the course here. Like I said, I don't like teaching this online. And so I'm trying to make sure that you guys are getting this information in the best way possible. And so if you have any recommendations for what you think should change, please give them to me on that anonymous link. I'll be posting it after the exam week. Keep in mind, I'm a human, so please don't rip me apart. If you don't like something, just let me know. Otherwise, if you do like things, please let me know as well, because if there's things that are working, I'm going to keep them going. And if not, I'll try to mitigate some things. But for the most part, this is really all I have for you guys. So I can do like 5 seconds here to ask one more question if anybody has one.
Appreciate the time.
Yeah, I appreciate you guys too. I hope you guys are learning a lot so far. If I don't have any further questions, I'll end the session here and I'll upload the review session for you guys. And good luck on your exam.
Thank you.
Thank you.
Well done.
Have
See
a
y'all.
blessed day.
Thank you. Have a good night.